Have you ever heard the term dry, as in keep your code dry? Dry refers to one of the foundational principles in programming. It stands for don't repeat yourself. On the surface, that sounds so easy to do. However, as you'll see in this video, there's a lot to think through when trying to get this right. Before we get started, I want to mention that today's video is sponsored by PVS Studio. PVS Studio develops a static code analyzer that detects bugs and potential vulnerabilities in your code. Not only does it work in C#, but it also works in C and C++, and Java support is coming soon. Check out the link in the description for more details. And while you're in the description, also note there's a link to a blog post for this video. That blog post also includes links to the source code for this video. Okay, let's look at our starter code. Here we have a simple WinForm application. We have just the dashboard form, and on it we have a couple of fields, first name and last name, where we're going to generate an employee ID. Obviously, this is a demo application, not something real world in that you probably wouldn't do it this way, but it represents real world stuff. Okay, so let's run this real quick just to kind of show off what it does do. So if I were to put Timothy Corey and hit generate employee ID, it takes my first 4 letters of my first name, the first 4 letters of my last name, and then puts a 3-digit code on the end. Now, this is probably the logic you've seen in a number of different applications you've looked at. If you look at the code behind for this, you'll see that there is a click event. Inside there is our code. Pretty simple stuff, but there's a problem here, and that is it does not conform to dry. And you may be thinking, well, yeah, it does because it only does things once, and we're not repeating ourselves. And that's kind of true. There's a little bit of repetition here I'm going to address, but that's not the only repetition to look out for. Okay, so we're going to address this one step at a time and kind of work our way into a really dry scenario, a scenario where we're set up for the future as well as what we have today. So let's first start by looking at the code we have. So a string employee ID gets created by taking our first name and taking the text field of that box. So that's right here. It grabs that text box and says, okay, give me a substring of that, and it starts at position 0 and give me 4 characters. So that's how I get my first 4 characters of my first name. And then it says, okay, last name text, and then a substring, and then 4 characters. And then we do at the end a datetime.now.millisecond. So right at the bat, you'll see a little bit of repetition in this call and this call. Now, you could say, well, I can break that off into a method. And yeah, you can. But here's the issue. You already have. It's called substring. Okay? So this is a method, and we've called it twice instead of actually doing the work twice. So I'm not really sure that's a place where we can eliminate much code or reduce our repetition, because it really is just calling a method and therefore not really repetition. However, imagine for a minute that this is not the only way we're going to create employees, because it probably isn't. Imagine if we get a list of new employees to create, and so we have this list of first names and last names, and we're going to generate employee IDs. Probably we wouldn't want to enter them one by one. We want to have some way of uploading all those at once, which means that this logic right here behind the generate employee ID, that logic is going to need to be called somewhere else besides in the click event. So there's a problem. Now we will have to repeat ourselves. So part of dry is not just saying, okay, have repetition, eliminate, make a method out of it, and then call it in 2 places. Part of it is looking ahead and saying, I am going to have repetition, therefore I will solve this. So the first way you can eliminate repetition or allow yourself to not repeat yourself in the future is to create a method. So here I would do something like this where I say, let's make a private void, and we'll say generate employee ID. I'm going to take all this code. We can cut it out here. We can paste it over here and then just call generate employee ID. Now, that didn't do a whole lot except for add one new method on the surface. But when it comes time to maybe make another button over here that says, process CSV file that has multiple in it. I'm not going to do that for time's sake, but let's pretend we're doing that. Well, then we can call this same generate employee ID, but we do have a problem here, and that is that we're expecting that we know where the first name and last name come from. So I think the next step is to say, well, actually, let's do string first name and string last name, and then pass those in like so. So first name text, let's do the same for last name text. Now we can call this method from somewhere else. It does not have to be on here. Now the last thing we have to look at though is we're assigning this employee ID to the employee ID text.text. That's also a problem because of the fact that we might not be writing it to this spot right here every time. Well, in that case, we can return a string, and then we can do this. We can cut this out and say return. And then up here, say employee text.text equals, and call the method. So now this is a little bit of refactoring right now, but what we've done is we pulled out the code behind for this click event and made it so that we can call this method, and it does not depend on getting the name from these two boxes, and it does not depend on putting the name into this box. This allows us to not repeat ourselves when we're not using the same exact form. Okay, so that's step one, is just make a method out of it. That way, when you create that second button that processes the CSV file, you have the code here. Now, imagine our boss comes to us and says, you know what? We need to rework our user interface. We need to have more power in the design. Maybe when I have animations, or when I use the graphics card for some reason, showing videos, those kind of things. Or we just want to have a nice resizable user interface. We just can't get that really well with WinForms. So we want to change over to WPF. And so go ahead and build a new user interface. So you come over here and you create this new user interface, and let's call it WPF UI. Now let's pretend this is a new project or you're starting over. And you need to basically recreate this, but in WPF. So I pre-wrote some code just to, kind of save some time here and laid the form back out, because that's not really what I'm discussing here. Let's go ahead and change the font size here. Let's make it 20 sounds good. All right, so we have this form now where we can fill in the first name and last name and click the generate employee ID and create the employee ID. So let's go ahead and create this event over here. Let's just do the click event. Click equals new event. And then we'll go to the code behind for that. And what do we do? Well, if we're in the repeat ourselves, we would copy this right here and paste it over here. And that's not what we should be doing though. We don't want to repeat ourselves. And so the next step in this process of d.r.y is anticipating the idea that you might want to change your user interface at some point, because user interfaces change and business requirements change. And that's where the next solution comes in, and that is the class library. So create a class library. We're going to create a .NET framework for now, and we'll call this the d.r.y demo library. And we'll get rid of class 1. Let's create a new class. We can call this, let's call it something like employee processor. Not a great name, but not horrible. Make it public, and we'll actually paste that method in. Make it public. And so now we have this public class employee processor. Right now, we don't need to instantiate it because there's not much to do here. We could make it a static class if we wanted to. It's kind of debatable if you want. Let's leave it alone. They've got some future plans for this that are even beyond what we have here. So let's leave it alone as a non-static class, meaning you have to instantiate it. So what we can do is now we can come back over here to our dashboard. We can cut this out because we don't want to have it in two places. One of the purposes of d.r.y is that we're not repeating ourselves, so we're not creating bugs for ourselves later. And here's the reason why. I'm going to show you a bug, and then we're not going to fix it now. I want to show you the bug first, just so you can kind of see the reason why we would not want it in two different places. So if I say TimCorey and hit generate employee ID, it crashes. And the reason why is because Tim is 3 letters, and I'm saying give me 4 letters out of that string. You can't do it. And so it crashes. Well, if I was a good programmer, I'd say, okay, I'm going to fix this. Let's just pretend this is the fix. It's not the fix, but to change it to 3. Okay? And I would run this, and I were to say TimCorey and generate employee ID, and it does. So I've, quote unquote, fixed the problem. I have not, but pretend I did. And I go, whew, I'm done. Well, there's a problem here. I didn't change it over here. And so this code will still crash under those same circumstances, where the other code won't. And so now I have code in 2 different places that are in 2 different states, meaning I fixed the bug in one place, but not the other. And you may think, well, that's, no problem. I can just change it in both places. I'll remember. Trust me, you won't. And maybe you will in a tiny project, but as the project grows, you won't. And as you have slightly different iterations of the code in different spots, it makes it much more difficult to handle. So if you have this in 5, 10, 15 places, you're just up a creek. And so what happens is you fix a bug and the bug happens again. You're like, man, I thought for sure I fixed it. And in fact, you had in one spot, but not in the other. And that's why you really, really, really don't want to have code that's very, very similar in 2 different places. So if you can, get rid of it. And now this is going to yell at us, but not a problem, because we can say, actually, it's employee processor. And I'll do a control dot here to add a reference to my d.r.y library. And I'll say, let's call it processor equals new processor. And now I can just say processor dot generate employee ID. And now I'm calling it over here in my dashboard of my WinForm project. So this form right here is now calling it correctly from the class library. Now I can come over here to my XAML, and the code behind for that is here. And I can say the same code, employee processor, do the control dot and add the reference. Notice the control dot allows me to add a reference and also add the using statement all in one. And yes, this looks very similar. And in fact, it is. It's instantiating the instance of an employee processor. But that's not repetition of ourselves. Not really. Okay, so we can say, let's get the name of our field here. Our field is called employee ID. So we can say employee ID.text equals processor dot generate employee ID first name.text and last name.text. And those are the 2 fields on our WPF form. So now if we set this as startup project, Let me run it. And I were to say the bug is still there, so we have to say Timothy, Corey, and I click generate employee ID, and it's the correct employee ID. Those last three are a random number, essentially. It's the milliseconds of when I ran this code. So that right there generates for us a employee ID on the Win or on the WPF side, as well as the Win form, and yet we're only using our code once. Okay, so there we've now gone a step further in eliminating repetition, but we're not done yet. Now, one thing before I go, just so you're aware, I want to be very clear on this. I said it's kind of like a random number, this right here, meaning it looks that way. Don't use the milliseconds as a random number. Okay, there's actually a random number class that does random numbers. I'm just using this to have something different on the end every time. That's all I'm doing it for. This is not a random number. Okay? All right. So now we've gone a step further and we have this dry demo library that we can use from either our WinForm project or our WPF project. And you may say, Tim, that's great, but here's the problem. I don't necessarily want to use a second UI in my same solution. Understandable. But maybe there's the same code used in other places in the organization. So maybe you do the UI stuff in this solution, but there's a different project that is just a Windows service. And what it does is it takes the forms that have been filled out on the website or something like that, and it processes them, and it creates our employee IDs that way. Well, how do you handle that? Well, part of the benefit here of the class library, if we right-click on this and open folder in File Explorer, and let's bring this down here. We go to the bin folder, and right now you've only compiled it in the debug branch, and that's fine. So let's go to debug. We have this DLL here. That DLL represents the code for this library. So let's do this. Let's create an entirely new solution. So let's close our solution. And let's do a new project. And let's just, for simplicity's sake, let's create a console application. Let's pretend this is the service. Typically, services are console applications or something similar to that. So let's call this our console UI. And let's call this our dry demo 2. Now in here, we want to do something similar. Let's start with console.readline. And in here, we want to call that same code we've already written. We don't want to repeat ourselves. Well, what we can do is add a reference. Now, built in, there's a whole bunch of references we can access in the .NET framework. There's also the other projects, but we don't have another project in the solution. We could go to shared projects if we wanted to, but let's go to browse instead. And we'll hit browse. Now what I'm going to do is I'm going to grab the path to our DLL. So I'm going to copy that. I'm going to paste it in here. And there's our DLL. The one we just pointed out, I'll just bring it on the screen. The one's in the bin debug folder. I just grabbed that specific DLL and I said add. I hit OK. And so you can see right here, the dry demo library is now in our list. Now, if you forget what things are in there, what you can do is say dry demo library dot, it's employee processor dot, and of course there's nothing you can do there. So you can say dry demo library dot employee processor, call it processor equals new processor. And you can say, well, that's really wordy. No problem. Now that you use IntelliSense to create it, you can delete the dry demo processor and just control dot to add a using statement. Or you can just write it yourself. But now you can say processor dot generate employee ID. and we need our first name and our last name. Now, we don't have one of these yet, so it's going to yell at me. Not a problem. Let's just say console.write. What is your first name? And then we'll say string first name equals console.readLine. It'll do the exact same thing for last name. So there's last name. And we'll read that too. And so now we've read the first name and the last name. We've generated the employee ID. So let's just say string employee ID equals. And now we can say is console write line. Let's do our $sign here. Let's say your employee ID is employee ID. All right. So now if we run this application, bring it over. Timothy, Corey, my employee ID is TIMOCORE 961. So the same code works now in a different application. So not only have I kept my code dry in my first solution, where I've been able to call it from one UI and then the next UI, I've also allowed myself to call it from a different UI entirely that's not in my solution by bringing in that DLL. Now, every time that DLL changes, you're going to want to bring in the new version of it. The good news is, and it's not going to cover in this video, but we're going to do it soon, is you can actually create a NuGet package for your DLL. And then you have a private NuGet server if you want, or a public one if you want to use a public one. But you can bring that NuGet package in and then use the normal NuGet package update routine that you normally would with any other package, but it's for your stuff. But we're not done yet. So let's run this again, and let's put in Tim and Corey again, and notice how it crashes. It actually crashes in our DLL, which is really cool because it's our DLL. It knows how to go right into that code, even though it's not in our solution. So it says, hey, there's a problem here. So we know we've got a problem with the first name. So maybe what we do is let's go ahead and open our solution. So we'll grab the dry demo instead of dry demo 2. And let's go ahead and fix this code. So we need to write some code for it, but here's the problem. If I fix this code for first name and I run it again, it all works, and I push this to production, I'm going to have to fix it again for last name at some point. Now I have to test it again. And here's one of the areas that people often overlook dry, and that is your development work. So before I start fixing this, I think the best solution and one of the ways we can better implement dry or not repeating ourselves is to add a new solution to our new project to this solution. Make it a class library. And let's call this the dry demo library tests or test project. Then let's go ahead and delete class 1. And then we'll add our references, our NuGet package references to XUnit. There we go. We can install that. Once that's done, we can go ahead and close this out. And let's add a new test class. So add class. Let's call this class the employee processor test class. All right, at this point, what we can do, make it public, And then we can add in our using statement for X unit. And then here, let's create our first and probably only test method. We can figure that out. So let's create a method that's going to look at the generate employee ID. So we'll call this the, let's say, public void generate employee ID should calculate. And we'll make this a theory, actually. So we're going to pass in first name, last name. And this is going to be the expected start, I'm going to call it. And this is a little tricky because of the fact that the whole string has that number at the end that's really hard to work with. And so it's hard to create a test for it. But we're going to do that, create this test, by saying, well, the first part of it should start with this. And that's what they do sometimes. Now, really what should happen is, and this is kind of getting into unit testing, and you can learn more about unit testing in my other videos, but really what you want to do is you want to take this out as a dependency, essentially. You're saying you're always going to go to datetime.now.millisecond and get a real value. And what you want to do instead is you want to mock this so that you're not actually returning the milliseconds, you're controlling what number gets returned here. That way you could try things out like, what happens when I return 1 instead of 001? Does it return 001? Probably not. It probably returns 1, but maybe not, because of the fact it's a decimal point. So you try to figure that out. So things like that. But then you can also control the entire employee ID. Imagine if this was at the start and the end. That might cause some problems. But in our case, it's pretty simple. We're just going to start with, what's the starter string look like? So let's create a theory here. And then we're going to pass in some inline data. And then we have our 3 things to pass in: first name, last name, and expected start. So let's start with something simple. So Timothy, and then Corey, and then the expected start is going to be TIMOCORE. Okay, we know that one works, but we're going to start with what we know works. So let's test this out. Now, if you're following along with the arrange, act, assert, then we already have the arrange, because the arrange is where you set up the expected, but we're going to set up the actual. So let's just declare that. Well, actually, let's go down here to declare that. So we'll say the string actual start equals, and then we'll make a call to our employee processor. So employee processor, control dot to bring in the demo library. We actually have to instantiate this first, so let's cut this out. Actually, that could be a part of the arrange though. There we go. Processor equals new processor. Perfect. You say processor dot generate employee ID with the first name and the last name. And then we're going to get the substring of just the first 8 characters. Okay, that's good to start, and we'll figure out why it's not good overall in just a minute. And the assert is that we can do a equals, where we say that the expected start and the actual start are the same. Now, if we run this in the Task Explorer, let's go ahead and run all and make sure this works. So let's first start by, let's pin that. Let's go ahead and build our solution. And I forgot something here. That's what happens. Every once in a while you forget something. In this case, I forgot to install the xunit.runner. There's a couple of runners here you want to install. The console, let's install that one. And we'll also install the Visual Studio runner as well. And that just tells Visual Studio how to run these unit tests. And once that's done, we should be able to run all. And there we go. Now we have over here a running unit test. Now, and this is where we want to save some time. Instead of running your application, getting to the right spot. Now, it's really easy with this application because of the fact that it's right there in the opening screen. And we actually know the bug too. But it's right there in the opening screen, so it's not hard to set up. But imagine this was 3 or 4 layers deep. Maybe you have this, this complex wizard builder system where the user goes through and puts their first and last name in, and then they go ahead and put their address in, and then their bank account information, their credit card information, whatever. And you get to the end, and that's where the bug is. Trying to recreate that every time is a pain. I know, I've done it. I do it every once in a while. And so this right here is going to save us some time, because instead of doing all that setup process to test out something else, I just do this. And let's just say I'm going to expect that this is going to be this, which I do need to change this unit test. Let's go ahead and unpin this. I'm doing a substring 8. That's not really right. Let's say that the substring should be the 8. Instead of 8, it should be expected start dot length. Basically the same length as what you expect. So if we run this again with a second theory, we get a broken unit test. Okay, one worked. That's the first one. The second one breaks. And if we bring up this here, it says index or IAM and length must refer to a location within the string. Basically, it's out of range exception, or we're trying to go 4 characters into a 3-character string. That's what it really comes down to. So now we found the bug, which doing it this way allows us to do it quickly and allows us to keep this around to test future versions or future fixes. So now we can come over to our employee processor and say, let's see how to fix this. Well, one of the ways to fix this, I think the best way is to actually create a new private method. Let's private string get part of name. Let's call it that. And we'll pass in the name that we want to get part of. Now, I could keep creating this method just as it is, but I want to point out one more dry thing, and that is number of characters. Instead of passing this magic string here of 4, or magic number, I want to say, hey, you know what? Down the road, you might change this. It might say 5 instead. Or in a different system, maybe the email system, where it generates the email address for the user, the new user, we might say 1 character from the first name and all the characters from the last name. So in that case, we would just say 1 here for number of characters. Now we could do substring as well, but now we have this that's a little more robust. Hopefully, it's going to be a little more robust, in which case we want to pass it through this instead. And so now we have this system where we can reuse this private method in this employee processor in more than one spot too. So again, we are keeping ourselves dry by not saying it's always going to be 4 characters, or it's always going to be first name or last name. So here, let's say that the string output, let's start it off as being let's just start off with an empty string. Then we're going to say if the name.length is greater than or equal to, in fact, you know what? Let's start it off, instead of being an empty string, let's start it off as name. And then say if name.length is greater than number of characters, then what we're going to do is we're going to say output equals name.substring, start at 0, and say number of characters. So if the name is Tim, we're going to put Tim into output. Tim.length is 3. 3 is not greater than 4, therefore we're not going to do this code. But if Timothy is passed in, Timothy's got a length greater than 4, therefore what we're going to say is Timothy, just the first 4 characters, therefore it's TIMO goes into output. Either way, return output. And now we can say get part of name and just say give me 4 characters of it. Like that. There we go. And now we're using this method instead. So if we don't have 4 characters, it's going to return however many characters we do have. So in the case of Tim, it would be 3 characters. Now if we come back over here and run our tests again and say, well, that's actually what we expected, 7 characters, not 8. So let's run our test again and see what we get for results. And now we have passing tests. Just to verify, let's go ahead and say that, in fact, my last name is C-O, just Tim Co. And that's what it should return. Let's run that again. And this time we should have, and we do, 3 passing unit tests. But you see what I did there? I cut down my development time and my debugging time and my testing time by not repeating myself. I'm not starting the application up, typing information in, hitting the button, seeing if it crashes, seeing if the results are right, and then going back and starting over and trying a different result. This right here is reducing or eliminating my repetition by saying, I'll try it for you over and over and over again. And now, if I come over here and say, you know what? I'm thinking that instead of saying, well, I'll just, return Tim instead of TIMO because we only have the first 3 letters, I think what we should do is we should return TIM and put an X at the end, an X for every blank space. Well, we could write that code. And we could say, you know what? If the length is less than 4, what we can do is do a do loop and say while name.length is less than 4. And here we can say name plus equals, and we'll put an X at the end. Now, it's not the most efficient code because we are appending a string. And if you're going to do that 1,000 times, that'd be very inefficient, or 100,000 times. But for our case, it's probably not a problem, and it's not worth the extra overhead to try and write something more efficient because it actually would take more work to do that. Just kind of pointing that out there. But so in this case, we're going to append X to the end. Well, first of all, just doing that change, which the boss might want, it's going to break our unit tests. Okay, let's just see that right now. And it doesn't. That's interesting. So we've got to figure out, I see why. I added to name. Isn't that awesome? My unit test just said, no, we're good. You're getting the output you expected originally, which was TIMCO, not TIMXCOXX. So I know right away I've got a bug in this code somewhere that I just wrote, but it's not doing what I want it to do. And the reason why is because I want output, not name, to be appended to. Now let's run it again, and hopefully it should break on me. And this time it does. 2 out of 3 broke. Well, why did 1 pass? Well, 1 is the full working copy. But now I say, well, the boss actually wants it to look like this. Whoops. Not CORE is fine, but TIM and the X there and the CO and 2 X's. Let's run this again and make sure that it, in fact, works the way the boss wants it to. And it does. I didn't have to open up my UI and run it and type in the information and hit the button to make sure it worked. So I've cut down on my code, but I've also cut down on all the work that goes around with writing that code and testing it and making sure it works and fixing the bugs and making sure those bugs are really fixed. And so all that is accomplished by writing a really simple little unit test. And so this right here, even though it's more coding, has actually saved me a lot of work, both now and in the future. So this really does fit under the d.r.y principle. We're not repeating ourselves, but it's not about code this time. It's about our testing and debugging. We're not repeating our same tests over and over again by doing it ourselves. We've written it once, we've done the test once, and now we just have it automatically run, or I click the button. Okay, so that's yet another way we can cut down on our repetition. It has not a whole lot to do with our code, but it has to do with how we approach our code, and that's where unit testing comes in. But we're not done yet. There's one more thing I want you to consider when we talk about creating a library. This library right now takes care of a WinForm UI, a WPF UI, and then a different solution, a console application. And that's great. It works across all these different user interfaces, and it will also work against ASP.NET MVC. But we're not covering all we could with this library. And so there is a repetition issue that maybe we can solve. And that is, if we right click on here and say add new project, instead of creating a class library that says .NET Framework, if instead we create a class library called .NET Standard, then what will happen is our code will be not only usable on Windows with all the WinForm UI and the WPF and console and ASP.NET, but it will also be able to be used by the .NET Core apps. It'll be able to be used in Xamarin, which is the front-end tooling for working on iOS and Android and Linux and Mac. And so now our code doesn't just save our repetition on Windows, it also saves repetition on these other platforms. So if you can do it, create a .NET Standard library. And it looks a little bit different, but not much. Okay, so I'm going to go ahead and delete class 1. And instead, I am going to create a new class, and we'll call this the same name. Make it public. And check this out. I'm going to grab the code from our old employee processor. I'm just going to copy and paste. And yes, copy and paste is usually bad, but in this case, we're moving it over to a new platform. And so there we go. So that's really all I did. And now we can call this .NET Standard library from WinForm, from WPF, from ASP.NET, but also from Xamarin, and also from .NET Core. And so now our code lives in more places. So we've again cut down on that repetition by allowing us to go to more platforms than just Windows. So hopefully you've seen that we started off with the code right behind this button. And while it didn't necessarily have much repetition in the code itself, it caused us to repeat ourselves when we created new applications or new functionality in this application. And so by moving into a method, we can call it again on this form. But then moving it into a class library like we did here allows us to call it in the WPF user interface. And it allows us to call it in other places by taking that DLL to the new solution. But then we can take it a step further by creating instead in the .NET standard, which allows us to go to other platforms as well. But then also we looked at, well, we're not only repeating our code work, but we're also repeating our effort in testing and debugging. And that's when we brought in the unit tests so that we can run those tests and try out those things in automated fashion so that we're not repeating our work as developers by launching the application and running through the process. We can test it out by just hitting the test button. So there's a lot of ways we can approach keeping our code dry. It's not just about saying, oh, I'm writing the same exact code more than once. But that is a valid area. It's just there's so much further we can take this to make sure that we don't repeat ourselves. Now the question may come up, how far do you take this? And do you always go to the .NET standard? And do you always write unit tests? And do you always do these things? And the answer is not always. And that's one of the things I want to caution you is you need to create for your situation, but still remember the future. So here are my general tips and tricks when it comes to this type of dry. Don't put code in the code behind. Don't put code in the user interface at all if you can help it. So this type of code we have here, this code, this does not belong in the user interface. There's no reason to put it there because we can genericize it enough so that we're not talking about this text box or this event or this button. We don't have to know that. We just have to know that you passed in information and that we pass back other information or processed information. So this really shouldn't live in the form project or whatever user interface you have because it's much, much easier to take code from a library and reuse it. And you may think, I'll never need it. But more often than not, you will. Okay? And if you're never going to need the code again, I'm concerned about your application because it's either really, really small or you're not thinking long-term enough or it's really a throwaway application because applications need to grow over time. And part of that is you may need to change your user interface. So whenever possible, this is one of my keys is whenever possible, put your code into a library. Now, as the .NET Core has evolved, I now recommend, whenever possible, put your code in a .NET Standard library. And the reason for the .NET Standard library is because you can take advantage of all the platforms that C# offers. And C# offers platforms across the board. So if possible, put your code in a .NET Standard library. Now, there is some code that will not fit in there. For example, if you are working with text files on disk or the config file, these are things that won't really fit in a .NET Standard library. What I encourage you to do then is create two libraries. One that is your standard library, your .NET Standard library, and that's where most of your code lives, the code that can live there. The code that can't live there, create a separate library. There are ways you can, in your .NET Standard library, have some workarounds. I'm not a big fan of those if you can avoid them. So it's probably simpler to create two libraries. And that way, the code that you can use other places, you have access to. And the code that you couldn't use other places anyways It's still a library, so it can still be used across Windows, just not across Mac, Linux, iOS, or Android. So that's my encouragement. As far as unit tests, I always encourage you to look into creating unit tests. Because like you saw, unit tests allow you to really speed up your debugging process. And you may think you don't write bugs. You do. Okay? Just in this demo, I wrote bugs. Now, some of those were intentional, but some of them weren't. And so being able to have that unit test back you up and say, yes, your code was good, saves you a ton of time and a ton of worry. Because right now, I am not worried about making changes to the generate employee ID method. If you ask me to do something different, so the boss came in and said, you know what? I want to put the X at the beginning. Not a problem. I will modify my unit tests to reflect what the boss wants, and then a little break. And then I'll change the code in here to what I think it should be. And then we'll try it again. And if the unit tests all pass, I'm good to go. I don't have to worry about, well, I should launch the application and try it out. I don't have to do that because the unit tests have done it for me. They have run through my code and made sure the inputs and the outputs match what I expect them to be. And that's really all I need to do. So I do encourage unit tests. Now there is a size level that you need to think through. If you're creating a very small application or a test project or something of that nature, you don't have to create a separate .NET standard library and then maybe a .NET framework library as well, and unit tests and all this stuff for what really is a simple test project or a proof of concept. So I don't recommend it for that. For a small little project that you're going to use in production, I still recommend the library and the unit testing. And the reason why is because typically what happens is small little production apps grow over time. And that's where you have a lot of our larger software has come from small little production apps. So I'd recommend getting started on the right foot with anything that goes into production. Okay? So that's my recommendations. I hope you've enjoyed it. Like I said, the links are in the description below. One for the sponsor of this video, PVS Studio. I want to thank them for sponsoring this video. But also a link to the blog post that has the code at the start of this demo and also at the end. So you can kind of see what I did, but also try it out for yourself. Okay? If you have any questions, please leave them down in the comments below. I try and get to all comments and respond if possible. Thanks for watching, and as always, I am Tim Corey.